Okay, for an electric circuit, you have to have a complete path or circuit from positive to negative terminals, and a gap in that circuit can be opened and the electron flow stops. Circuits can be parallel or series, and we'll look at the series circuit first. So this would be a series. This would be like, say, a light bulb or something like that here and here. And that would be a schematic of it, and this would be the power source, like batteries. What happens in a series circuit is that current flows through all the lamps. Electrons leave the negative terminal of the battery, pass through each of the resistant filaments in the lamps, and return to the positive terminal. A break in wires or a filament break in lamps disrupts the flow and all the lamps go out. So when Christmas lights first came out, they were in series circuit, so if one of the bulbs went out, the whole line went out. And they're made differently now, but if you ever watched like Christmas Vacation, you had to check each one of those bulbs because they were in series. Electric current has a single pathway through the circuit, and the current is the same in each electric device connected to it. The current is resisted by the resistance of all the devices, so the total current is the sum of all the resistance from all the devices. The current will be equal to the voltage supplied by the source divided by the total resistance of the circuit, just going back to Ohm's law. Ohm's law also applies separately to each device. The voltage drop or potential difference across each device depends directly on the resistance. More energy is used to move a unit of charge through a large resistance than through a small resistance. And the R equivalent, I need to correct that, is going to be 1 over R. And so, oh, that's okay, but we'll, oh, actually, that's fine. Okay, the current is the same for each resistor. The voltage is different across each resistor, and you add them up to get the total voltage. Resistance of the circuit is the sum of all the resistors. So if I had a series, what I'm going to do is to take my 12-volt storage battery, connecting it to 3 resistors of 8 ohms, 10 ohms, and 12 ohms respectively, and basically the resistance equivalent is going to be equal to the 8 ohms plus the 10 ohms plus the 12 ohms. Okay, so we have 30 ohms of resistance total. I can then get the current by taking the voltage over the resistance. And so the voltage here is a 12-volt battery divided by 30 ohms of current, and I'll get 0.4 amps of current. 30 ohms of resistance, 0.4 amps of current. And to answer the last 2 questions there, that's the current in the circuit, and that's the current in each resistor in a series circuit. In a parallel circuit, notice these are not in order, they're parallel to each other, and this would be a parallel circuit. What's different about a parallel circuit is that each device connects to the same 2 points, A and B, of the circuit, so the voltage is the same across each device. The total current in the circuit divides among the parallel branches, and current is going to pass more readily into devices of low resistance, and Ohm's law will apply separately to each branch of the parallel circuit. The total current in the circuit equals the sum of the currents in its parallel branches. As the number of branches is increased, the overall resistance of the circuit is decreased. So overall resistance of a circuit is less than the resistance of any one of the branches. Current is different in each resistor. The total current in the circuit is the sum of all currents, and the voltage is the same for each resistor. So how we're going to do this for a parallel resistor, or a parallel circuit, is to take the resistance of each circuit, and we're going to sum up the reciprocals, and that will equal 1 over the resistant equivalent. So as an example here, we'll take the 6.8 ohm resistor, the 8 ohm, and the 16 ohm, and connect it in parallel across a 24-volt battery. And what is going to be the resistance and the current? Okay, so what we're going to basically do is go equivalent here, equal to 1 over 6.8 plus 1 over 8 plus 1 over 16. And basically we get, you go ahead and calculate that yourself, but when you get that, you're going to get 3 ohms. So I just took these, added those up, and then I took the reciprocal of this whole thing, and I got the equivalence resistant. Okay, then the current is going to be voltage over resistance. So 24 volts over 3 and 8 amps. But now how is that going to get broken up? Because each resistor is going to have a different amp through it, total of 8. But how is each one going to get broken up? Well, for the 6.81, what I'm going to do is go 24 divided by 6.8. I'll get 3.5 amps. For the 24 volt and the 8, I'm going to get 3 amps. And for the 16 one, I'm going to get 1.5 amps. And that's how it gets broken up. Okay, we also can have two different kind of resistors. Or circuits. We can have a parallel circuit and a series circuit. And here are the rules for adding up resistors in a series and parallel. What we're going to do here is we're going to look at these. These are in parallel. So these two are in series, so that's 8 ohms, okay? But now the 8 and the 4 are in parallel. So what I'm going to do for this right here is I'm going to find the resistance by taking 1 over 8 plus 1 over 4. And what I get for this little chunk right here is 2.66 ohms by doing this, because these two are in parallel. And now what I have for this little whole chunk right here is 2.66. So then the 3, the 6, the 2.66, and the 1 are now in series, like so. And so now what I need to do to find that is to take the resistance and just add up the 3 plus the 6 plus the 2.66 plus the 1. And we'll get 12.66 ohms total resistance for this circuit. Okay, it's kind of some interesting things. Parallel circuits and overloading. Electricity is fed into the homes by way of 2 lead wires called lines, and these lines are pretty low resistance, connected to wall outlets in each room, and about 120 volts are impressed upon these lines by the generators at the power utility. This voltage is applied to appliances connected to the wall outlets. But you can have an overload. You've probably blown a circuit or blown a fuse before, and what you've basically done is short-circuited the circuit. It just could be too much. You get too much current flowing, the insulation wires get too hot, you could start a fire. And so there's a built-in break point where it just, it'll break the fuse. So let's say you got a space heater, a toaster, a lamp, all operating on the total line current, and increases to the total amps they all need. The fuses are connected in series though, so that the current must pass through the fuse. And what you're going to have to do is probably turn one of those off, replace the fuse, or push and pull. You used to have to actually take the fuse out, put it back in. Now you can just turn it off and turn it back on. But you should probably correct the problem. There's an issue here when you have a fuse blown. One of the things should get turned off. And that's it. You should be able to do the rest of the problems in the packet.